Okay, question 4. Find the binomial expansion of 2 plus x to the 5. You've got a number of different choices. Why are you laughing, Josh? You're just enjoying the video. We could use Pascal's triangle, or we could use the formula for doing this. It's one we're going to expand the whole thing. I'm going to think of it as being, well, I like this expansion, it's really nice. If we're going to do the expansion of this, we're going to get 2 to the 5, and then the next term, well we know, don't we, that the next term is always the same as the value of the power, so this is 5 times 2 to the 4 times x. And then if we're using Pascal's triangle, we remember that that row, you know 1, 2, 1, and then 1, 3, 3, 1, and then 1, 4, 6, 4, 1, 1, 5, 10. So the next value is going to be 10. If we don't do that, we're going to calculate this. We're going to do 5 factorial over 2 factorial, 3 factorial. And that's going to give us our value of 10 anyway. And that's 2 cubed x squared. And then we get the same coefficient again. 5 factorial over 3 factorial, 2 factorial, 2 squared, x cubed. Isn't it lovely how the powers all match up so that the powers are the same as the numbers on the bottom here, they all add up to 5. Oh, it's brilliant. And then we got 5 factorial over 4 factorial, 1 factorial, 2 times x to the 4, and then we end up with our x to the 5, and there it all is, looking lovely and unsimplified. So we need to work on this now to get 2 to the 5, 2, 4, 8, 32, plus 5 times 2 to the 4, or 2 to the 4 was 16, so 5 times x, 80x, plus this would be 10 times 2 cubed, which is 8, so that's an 80 as well. Then what have we got? We've got a 10 times a 4, so we've got 40x cubed. We've got 5 times 2, so 10 x to the 4, and we end up with x to the 5, and I didn't quite fit it on one line, but that would be alright. Which is great, and loads of you got full marks for this. There were some people who felt the need to then turn it round and write it starting with the biggest power of x. But actually when we're doing binomial expansions, we normally leave it written in ascending powers of x. I know you normally write polynomials in descending powers, but the norm for this is to write it in ascending powers. So leave it like that. That is fine. Part 2 was where it went wrong for lots of people. And this bit, don't underestimate the importance of the word hence in questions. But some people tried to start from scratch with this, and there was some very brave multiplying out of brackets going on as people tried to start from 2 plus 3y plus y squared and multiply that by itself, and then multiply that by itself again, and then multiply that by a final 2 plus 3y plus y squared. And terms were appearing all over the place. It was quite terrifying to see what was going on. Actually, how can we make this a hence thing? Well, we started with 2 plus x, so we need to turn this into 2 plus something. And the something is that bit there, our 3y plus y squared. So actually what we're looking for here is this expansion where x is replaced by 3y plus y squared. That's what we want to do with this. We want, for part 2, we want this to be that is what we're going to think of that is that is the same as 2 plus brackets 3y plus y squared to the 5. That is going to be our x in our expansion. So our expansion is going to look like 32 plus 80 times 3y plus y squared, plus 80 times 3y plus y squared squared. And actually, let's think carefully about what the question is asking us for. It's asking us for the coefficient of y cubed in this. So I don't want to do too much. I don't want to go on forever with this. I am going to need the next term though, aren't I? The next term would be 40 times 3y plus y squared cubed. Now that's still going to give me a y cubed term, but the next term, which would be 40 times, so it would be 10 times 3y plus y squared to the 4, that's the smallest term that I get from that is going to be a y to the 4 term. So I'm not actually going to bother writing that down. The rest of it would be okay. So let's think about what bits of that would contribute a y cubed term to our final answer. Well, the 32 and the 80 times this bit wouldn't. We wouldn't get a y cubed term from those. This bit, if we square this out, we are going to get one. So let's think about that bit. 80 times 3y plus y squared. That's 80 times, now be careful with this, if I multiply out this bracket, again, 9y squared, 3y times 3y, plus 3y times y squared, which is 6y cubed, plus another one, so that's 12y cubed, plus y squared times y squared, so y to the 4. Okay. Sorry, I've added this twice, haven't I? Did you notice that? This is a 6 in there. We've got 3y times y, which is 3y times y squared, plus 3y times y squared. So that's just a 6y squared. Sorry. And the other term, the 40 term, 40 times 3y plus y squared cubed. Well, I don't want to do too much work on this. If I multiply out all of this stuff here, my first term is going to be 3y all cubed. That's 27y cubed. All the rest of the stuff that comes from multiplying that out will be bigger powers of y than 3. So I'm not even going to bother working them out. Those are the only two places that I get a y cubed. So my answer, my coefficient of y cubed is going to be 80 times the 6 of them from there, plus 40 times the 27 of them from there. They are the only ways that I could make a y cubed out of that expansion, and that gives me a total of 1560. That's my answer. That was a bit that really stumped people. From memory, not many people got the marks for that, did they?